Everyone. We're starting notes 3.3, which are on properties of quadratic functions, and it starts on the bottom of page 5. So the first thing that it asks us to do is to use the graphs of quadratic functions a and b to fill in the table and answer the questions on the following page. So if you guys take a look right here, we have our first graph right here. This is graph A. And I want to just fill in the table right here. So if you notice, we have the coordinate -1, 8. We also have the coordinate 0, 3. So if I look right here, I have a coordinate 0, 3. I also have a coordinate of 1, 0. I have a coordinate of 2, -1. I also have a coordinate of 3, 0. I have a coordinate of 4, 3. And then I also have a coordinate of 5, 8. And then it keeps going on in both directions, but this is essentially the basic part of our graph right here, the initial part of our graph. So same thing right here, we have another table and we have a graph. If you can fill in the missing values for me, please, and then come back and check what you got, that would be wonderful. Right, so these are the values that you should have gotten. So double check to make sure you agree, and then we're going to move on to the chart on the next page. And I apologize in advance, you are going to have to flip back and forth, and it's going to be a little bit annoying, but it's really important that you're really following along with this, because this is the basis for all quadratic functions. Okay, so if you guys notice, we need to find the axis of symmetry, the vertex, whether the vertex is a minimum or a maximum, the y-intercept, the x-intercept, and the roots. Okay, so we're going to do 1 through 6 all on the graph right here. So the first thing that we're asked to find is the axis of symmetry. So if you guys notice right here, the axis of symmetry is simply the line that cuts your parabola in half. So if I were to graph out my axis of symmetry, I would see that this line right here is the line that cuts my parabola in half. And what ends up happening right here is that I end up getting x equals 2 because it's a vertical line. So this right here is the equation for my axis of symmetry. And I want you to draw in all of this information into your graph because this is key for this unit, okay? Then it also asked us to find the vertex. Now the vertex is just going to be right here at the highest point or the lowest point. So your vertex right here, also known as your turning point, is going to be 2, -1. Now, if you remember, it's not a coincidence that this value right here, this 2 right here, is the same value as this 2 here, because the axis of symmetry will always cut through the vertex. So they always share that x value. Okay, we also need to determine if it's a minimum or a maximum. And just by looking at it, it's the lowest point of my graph, so it's a minimum. Okay, so right here, our vertex is going to be a minimum. Okay, we are also asked to find the y-intercept. So if I were to look at my graph right here, where does my graph cross the y-axis? I can see that it crosses my y-axis at 0, 3. So 0, 3 is going to be my y-intercept. Then it asks us to find our x-intercepts, and our x-intercepts happen where the graph crosses the x-axis. So that means that I've got 2 x-intercepts in this example, and my x-intercepts are 1, 0 and 3, 0. Okay? And then lastly, it asked us to find, the last thing I wanted to talk about were your roots or your zeros. Your roots or your zeros are simply where your x-intercepts are, but they're only the x values. So my 0 would be 1 or 3, or my roots would be 1 and 3, okay? As opposed to an x-intercept where it's an entire coordinate, okay? So let's go ahead and fill in that information. So our axis of symmetry was x equals 3. Or sorry, our x equals 2. Our vertex was at 2, -1. It was a minimum. The y-intercept was 0, 3. The x-intercepts, remember, are our coordinates. So our x-intercepts were 1, 0 and 3, 0. And we put them in these brackets to indicate a set of answers because we have 2 different answers. And then our roots are just going to be 1 and 3. But again, we put it in brackets like this to show that it's a set of answers. Okay, So now, before we go on to number 7, I want to point something out to you guys that's really important. If you notice, the x-intercepts were at 1 and at 3, but the axis of symmetry happened at 2. And it's always going to occur that way. The axis of symmetry will always be halfway between 2 points of symmetry. Okay? So here, our 2 points of symmetry were our roots. Okay, but for example, right here we have 0, 3, and then this point right here is 4, 3, and the axis of symmetry still occurs halfway between these 2 points right here. Over here we have -1, 8, and we have 5, 8, and x equals 2 still is going to happen halfway between them. So that's always going to be important for you to know. So go ahead and find f of -1 and 5. Remember, f of -1 means find the y value when x is -1, and f of 5 says find the y value when x is 5. So when I look at my graph here, f of -1 is 8, and f of 5 is also 8. Okay, and I can also look at my table to figure those values out. So when I fill this in, I'm going to say f of -1 equals 8, and then f of 5 equals 8. And then it says, is f of 7 greater than or less than 8? And explain. I want you to do that on your own, and then we're going to talk about that together as a class next time I see you guys. Okay? Next thing it asks us to do is to determine the domain and range of the function. Well, remember, every parabola will always satisfy, like we can plug in any x value into any equation of a parabola and we'll always get a coordinate. So my graph right here has a domain of all real numbers because it goes on forever in both directions horizontally. Okay, so we're going to say that our domain is equal to x is an element of all real values. But when we have a parabola, the range is restricted because it has a vertex, a turning point. It has a minimum or a maximum. So here, my minimum value right here is at -1 for my y value. That's the lowest y value I have, and everything above -1 will work. So we can say here that for my range, y is an element of the reals such that y is greater than or equal to -1. Okay? And then lastly, the equation we're going to do after we fill in standard form, factored form, and vertex form for quadratic functions. Okay? We're going to do that in a little bit. The next thing I want you to do is to please complete sections 1 through 6 for graph B, and then come back and compare your answers with mine. Just like we did on the previous graph right here where we actually labeled it on the graph, I'd like you to do the same thing as well. Okay? All right, so you should draw your axis of symmetry through your vertex right here, and the equation that you should have gotten for your axis of symmetry was x equals -2. The vertex should be -2, 4, and it's a maximum. The y-intercept should be 0, 0, and the x-intercepts are -4, 0, and 0, 0, which means that your roots should be 0, -4. Okay? Now, this next part right here, find f of -1, f of -3, and predict the value for f of -6 and explain. I want you to do this as well, and we'll talk about it next time I see you guys in class. Okay? All right, now we're going to do the domain and range of the function right here. Well, to find the domain, we're going to see that this graph, any parabola, is going to have all real numbers, again, because it goes on forever in both directions. So our domain is still going to be x is an element of the reals. Now our range, though, this time we have our vertex is a maximum. So that means that our highest point is going to be a 4. So this time what we're going to say is that y is an element of the reals such that y is less than or equal to 4. And then one other thing I wanted you guys to notice was that the roots were 0, -4 right here, and your axis of symmetry was x equals -2, which is halfway between 0 and -4. Okay, so now we're going to write our equations for quadratic functions. So there are 3 different equations that we're going to be using. The first equation is f of x equals ax squared plus bx plus c, which you all should be familiar with. The second equation is going to be f of x is equal to a times x minus r times x minus s. And this right here is the factored form. And when you have a factored form right here, x and, sorry, not x, r and s are going to be the roots of your function, okay? Now, one thing I forgot to specify here is that a is not allowed to be 0, because if a is 0, this x squared here completely cancels out, and then it would just be a linear function, which is not possible for a quadratic function, okay? Lastly, vertex form is something that you should probably also be familiar with, and that's f of x equals a times x minus h squared plus k, and we talked about it in the last video as well. And in this case right here, h comma k is going to be your vertex, okay? But same thing, a is not allowed to be 0, because otherwise this whole thing will cancel out and it's just a k, okay? And same thing here, a is not allowed to be 0, otherwise the entire expression will cancel out on this side right here, and it would just be f of x equals 0. Okay, so now we need to find the equation of graph A. So standard form isn't going to be really that helpful to me right now. I'm either going to use factored form or vertex form, okay? I'm going to do graph A using factored form, and then I'm going to do graph B using vertex form. And I want you to see that either way, you'll still get the same answer, okay? So factored form says f of x is equal to a times x minus r times x minus s. But here we know that r and s are our roots. So if you take a look right here, we figured out that our roots were, were 1 here and 3 here. So we know for a fact that our equation is going to say f of x equals some a value times x minus 1 times x minus 3. But I need to figure out what the a value is. So I need to plug in any point other than a root to solve for a. So right here, what I'm going to do is I'm going to plug in, how about I plug in my y-intercept, because this is another point that's not my root, okay? So I'm going to plug in 0, 3. You can plug in any point you want, again, as long as it's not a root. So instead of x, I'm going to plug in 0, and instead of y, I'm going to plug in 3. So instead of f of x here, I'm going to say 3 equals a times x is 0 minus 1, and then here x is also 0 minus 3. So I get 3 equals a times negative 1 times negative 3. So I get 3 equals negative 1 times negative 3 is 3. So I get 3 equals 3a, so a equals 1. Therefore, my equation is going to be f of x is equal to 1 times x minus 1 times x minus 3. But this 1 here is not necessary, so this is going to be my equation right here. Okay, all right, so now what about if I had, I want to do vertex form for this guy right here. So vertex form is f of x is equal to a times x minus h squared plus k. And here I know that my vertex is negative 2, 4. Okay, so what I'm going to do is I'm going to plug in my vertex into my function right here. And I know hk is my vertex, and I know negative 2, 4 is my vertex. So it's going to look like this. F of x is equal to a times x minus negative 2 or plus 2 squared plus 4, because the k value is 4 right here. Then I'm going to plug in any other point. This time it can be anything I want as long as it's not my vertex this time. So this time what I'm going to do is I'm going to plug in my y-intercept again, because it's still not my vertex. So I'm going to plug in 0, 0. Sorry. So right here, I'm going to have 0, 0. So instead of f of x, I'm going to have 0 equals a times 0 plus 2 squared plus 4. So I get 0 equals a times 2 squared plus 4. 0 equals 2 squared is 4, so I get 4a plus 4. I'll keep solving up here. Subtract the 4 from both sides, and then divide by 4, I get negative 1 equals a. Therefore, my equation is going to be negative x plus 2 squared plus, plus 4. Okay, and that's pretty much it. Let me know if you have any questions. Have a great day.